Nelson, and I'm with the Civil Engineering Technology program here at Madison College, and I'll be going over a grain size distribution for coarse aggregate. Coarse aggregate is rocks and gravel and part of sand, and these all vary with different sizes, as you see here, and we want to find the percentage of the material that is a certain size, and the ending should be a graph. This sample is pulled from the field, and this has moisture in it within the pores of the rock. If you can see even the little dimples in the rock which the water would be held. This sample was already oven dried. The first step is to oven dry our sample to remove the field moisture. We would set the sample in the oven and place it at 230 degrees for 24 hours. We then take the cooled down sample and we will throw it on a scale and attain the weight with the pan and the dry material. Be sure to record the weight, and the weight is including the pan. We are working in grams. The next step in the process is to assemble the sieve stack. Each of these are a sieve and can be removed and placed on. They all each have an opening size and openings per inch in millimeters and in inches. And notice the different sizes, and notice how they are also getting from largest opening down to smaller openings. This is the sieve stack disassembled. We would start with a pan, since some of the material might pass through even the finest screens. So we then take the most fine screen, which is, in our case, a 200 sieve, meaning 200 openings per inch, followed by a 100 sieve, where is it there, a 50 sieve, then a number 30 sieve, a number 16 sieve, a number 8 sieve, a 4, and then this one is a 3/8 sieve, followed by a 3/4 sieve, and finally our cap. Once you got the sieve stack assembled, you can then just dump the material through. Make sure to get all the material into the sieve and none out of the sieve, as that would truly be good. Make sure to get all of it. From there, put on the cap to make sure none of the dust or fines get out. And then we'll take it over to the rototap. This is the rototap machine. I will not start it, unfortunately, due to safety, but this bar is the bar that would tap it as this rotates. Once the material is all shaken through the sieves, we will then go back to the scale, record the empty weight of the pan. We will then arrange our notes or to record the sieve size and the weight retained on the sieve. We will then zero the scale to having the pan on it. We'll then open up the sieve stack, take the first sieve, which is our 3/4 sieve. Notice the material is being held in there. Make sure to get all the material and then record the weight. We will then repeat the process for the following sieve, which is our 3/8 sieve. get all the material. We then want to record the cumulative weight retained. And then, for simplicity, just simply put the sieve stack upside down so that way the sieves stay in the right order. Notice how the sample is getting less and less with every sieve, meaning we are close to the end. If no material is on the sieve, simply keep the retained weight for the sample. The reason why we keep the retained weight on the sieves that don't even have anything on is since we've already had almost a gram of this P200 material. And our pan is also going to add weight. Once we recorded the pan's weight, we reassemble the stack and we can discard the sample since that is all we need from the sample. And next is our data, which we are going to turn into a gradation graph showing the sizes of the material that's in here. I rewrote the data so it is easier to follow and a better handwriting. So we want to find the oven dry weight of the sample after it was oven dried and the complete sample that was tested on. To find that, we need to subtract the pan from the oven dry weight that we recorded earlier, and then we get the oven dry weight. After that, we will take this final pan amount of the cumulative weight retained and then subtract that from the oven dry weight and then divide it by the oven dry weight, times it by 100, and then you get the percent of the sample that was lost throughout the test, which could be either stuck in the sieve sack or has simply slipped out of the sample, or multiple of the two. And if you see my sample, I only lost 0.08%, so we are good. If it's okay if it's under 2%, so make sure to record that data. Next, calculate the percent passing each sieve. To do so, just take the weight retained divided by the weight retained at the bottom here and times that by 100, and then you get the percent passing. I drew the example for the first two and then just did the rest. Next, we record the percent retained. To achieve that, all we take is the percent passing and 100 minus that. Next, we would get a grain size distribution chart. If you notice, there's the size on the bottom. This size represents the sample that the sieve is opening to. So if you notice on the top, it has the standard sieve sizes, and those dashed lines equate to the bottom 2 millimeters. And this is a logarithmic scale, so the distance between 1 and 2 is, the middle is about right here. So if you notice how everything gets kind of squished out to the end, that means that most of the sample is right here and kind of pushed over to the side. But if you notice, I plotted all the marks from our percent retained. So I got the 85% here from this one right here, the 12 right here, and the 0.2 down here. And then everything after that is such a low percentage that I'm not even going to be able to graph the distance or difference between. Next, draw a line of best fit. Fortunately, mine missed a little bit, but just try to make the line nice and neat, and then from there, we have the percent finer by weight over the size. And when you see the majority of the sample is between a 3/4 and 3/8 of an inch. And that is it.